We're living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE, welcome back to the channel that does to stupidity what Rockstar Games have done to their reputation. Good job, guys, good job. You could have just released GTA 6, but no. Tonight we're going to have another discussion about the shape of the Earth. We are speaking with a gentleman from Facebook called Benjamin. He's told me that this is the first time doing this, so going to try and be as nice as possible. You know how these things tend to go, but let's just let him introduce himself. Benjamin, welcome to the show. How you doing?
I'm doing all right. How you doing?
I'm doing pretty good. Would you just like to take a couple of minutes to introduce yourself and let people know your position on the shape of the Earth?
Yes. So my name is Benjamin Cole. I live in Tulsa, Oklahoma. Born and raised here. I used to believe in the globe. I haven't ruled it out in full, but I don't think that a lot of things work out on the globe theory. Tonight I have a pad and paper. That's just for descriptive purposes while we discuss. Everything that I'm going to discuss or answer is going to come from my head. I don't have any books around or any links to give anyone besides just telling them, hey, do your own research on the talking points.
Okay, thank you. I do appreciate you taking the time to come and speak to me, Ben. And I know, like I said, this is the first time we've done anything like this, so I'll try and be as nice as possible. Thank you, everyone, for watching. I do appreciate you taking the time to turn up. If you have not shared the stream with one of your friends, then that would be an excellent thing to do to help get more of an audience in. But let's just get on with it. Ben, why don't you just you can have up to 10 minutes, but you don't need to use 10 minutes, but just present your main bit of evidence that would support for you the Earth not being a globe. Is that right?
Yes.
Okay, over to you, Ben.
So, I guess one of the things that have come up recently that I've seen was the crepuscular rays, whereas clouds are in areas and light is casting through, through the clouds. So they say take the 2 points where they touch the ground and measure that distance. And then from those distances, go up to where the light source shines down its rays. And they say that it is 3,000 to 4,000 miles up. Water on any plane always finds its level. So coming down from mountains, creeks, streams, rivers, it always finds level, and level is the sea. That's the most level. It should be the most level place around the Earth where all water is touching around either the globe or being surrounded in land by water. And so people stand on the shore with telescopes and look out. So if we say there's a curve, what is the circumference? And it basically boils down to about 25,000 miles in circumference. So what is the equation? Well, they don't like the normal equation because they say it's for hyperbole. So they give another equation. Regardless, if a ship is out so far, they say it goes over a curve, but if you take the telescope and seek the ship, you still see it because we see in a straight line through the telescope. The equation that they give us for the circumference, it never allows for that site. It shouldn't, because with the curve, we would really see nothing but the sea because it's curving over. But if we see farther than the distance of what the equation is giving, what does that mean? I think it's flat. I think we're surrounded by all the waters, and they circumnavigate on like a pond, like a big sea, only separated by land. And then around that, with the cycle of the sun and the moon, is an ice wall to where light dissipates just enough to keep that all melted, if that makes sense. Just enough. But all our land is here. And what they circumnavigate is flat around all the lands. Admiral Byrd went to a place called the Summer Gate where it was open, and he followed it on out. Where did he go? If he's still seeing all this land, if he's going past all of that, where is he going? Nobody has went around from one top to another bottom. They've all circled this way and touched lands accordingly. So let's go from there and discuss that maybe.
Okay, right, no worries. So your first point was crepuscular rays, right?
Yes.
So are you claiming that you can use the angles of the crepuscular rays to calculate, well, to triangulate the position of the sun?
Yes.
Right. Well, can you see my screen okay? I need to show you this photo, for instance. This is called anti-crepuscular rays. And you can see it coming from the ground. Here is another one. I think this one is on a beach in Texas. This one is from a coast in Ireland. So where would the sun be in these pictures, according to the crepuscular rays?
The sun is still above the clouds. You can see that obviously because the sun is a white sun.
Okay,
And
so
if the clouds are lit up on the top white, that means they're out of any particle haze or pollution haze. That's clear and free due to, not so much up that high. There's not that much pollution. It doesn't go that high.
So in this particular picture I'm showing right now, the sun appears to literally be coming from underground. There's no clouds or anything. The crepuscular rays are rising up from the ground. So according to your theory, the sun would be behind the horizon in this picture.
Yes. It's behind the horizon due to vanishing point and perspective.
Okay, so these clouds in particular are cumulonimbus clouds, which tend to be less than 1,500 meters above the surface of the Earth. So these particular clouds, having the sun in the clouds, would mean that the sun is less than 1.5 kilometers above the surface of Earth.
The clouds are lit up. If you
Correct.
were to see these pictures, if you were to take this picture, you're looking directly at either east or west, whether that's morning or whether that's evening, right? Because that's when the sun is either setting or rising. So you'll be looking directly at that. But if you were either more north and looking down and back at where the sun would be, those rays would still be shining down, touching the ground.
except that they're not. They appear to be coming up from the clouds, which, again, these are particular type of clouds that stay less than 1.5 kilometers, above the surface of the Earth. So it would mean that the sun was in this cloud, and that would also mean that the sun is less than 1.5 kilometers above the surface of the Earth. So,
No.
and
We're
crepuscular rays in
at-
general are actually quite interesting. I live in Scotland in a place called Fife, and I've got a river next to me called the Firth of Forth and Edinburgh the other side. And there's mountains all around, and we get the most amazing cloud breaks. And you can drive along the coast and see the crepuscular rays coming, and they change position as you go past them. They literally, as you go past them, they can go from being splayed out to being straight to being splayed out again, meaning that it's actually an effect of perspective, because if you were to try and calculate the position of the sun, depending on where you were, you would get different results. Which means that it can't be, a thing that you can use to say, well, that's where the sun comes from. The fact is the sun rays are coming in parallel, or practically parallel to us. And the only way that we see the crepuscular rays is because we are looking at them from a particular angle. It's a very rare case where the actual answer is perspective.
Okay. So, if we get crepuscular rays, why is it from anywhere? Like here in Tulsa, it looks like the sun is crossing maybe the Texas and Oklahoma border. Like that's where it's above. So it looks close to us. Now, when, let's say, we have foggy days where the clouds may be up 2 miles and just be kind of a thin thick. And when the sun shines through, the sun looks like it's literally not that far behind the clouds.
Yeah,
but
that's perspective, isn't it?
When you also look at it through that filter of clouds, the sun is like a pure white ball.
Well, yeah, if you do look through a filter, it removes some of the light. But the position of the sun, my point is that the position of the sun would be different based on where you were looking at the crepuscular rays from, which shows us that it's actually a result of perspective and the sunlight coming in parallel to us. Because it's impossible to use these rays to calculate the position of the sun, because based on where you are, you would get conflicting results. And I also have many other issues with the sun being relatively close to us. Say, what did you say, 3,000 miles?
It's in between 3,000 to 4,000 that they know of.
So
that's been calculated.
Let me pose this question to you. If the sun is 3,000 miles above us, specifically, and the temperature at the bottom of Mount Everest is, say, 15 degrees centigrade, what would we expect to happen to the temperature as we climbed Mount Everest and got closer to the sun?
I would say you'd probably just be entering that area of atmosphere that's like pure, kind of clean of pollution. And so you'd either have some kind of, I don't know, bodily reaction, especially to the cold. I don't know. That's something that I've never really discussed.
Logically, if the sun is 3,000 miles above us, as we climbed Mount Everest, it would make sense that it would get warmer as we got closer to the sun. But at the top of practically every mountain in the world, you find much lower temperatures, even snow, which kind of doesn't make sense if the sun is that close to us, because as we got closer, it should get hotter. Now, airline pilots fly, 30 to 40,000 feet, right? They're much closer to the sun than any of us, yet the temperature on the outside of planes is usually in the negative, which doesn't make sense because they're even closer to the sun. So I just don't think that it logically makes sense to suggest that the sun is that close to us, because we can use radar to measure things like that, and you can't measure the distance to the sun as being 3,000 miles, yet you can use lasers to bounce off of retroreflectors left on the moon and show that that's 250,000 miles away. So the answer to the crepuscular rays is it's simply a matter of perspective and the way that you are looking at parallel rays of light coming into you. And it does not give evidence to a small and local sun.
I mean, all you can say to that is that's perspective. We can look down the street and see that vanishing point happens after a mile and a half. You know what I'm saying? Like, you can look down your neighborhood street and see that everything is getting smaller as it gets further away and into a vanishing point. So just on that small scale, seeing that you can't see that far.
Well, we can definitely, if we assume the sun is in the sky, well, we don't need to assume that the sun is in the sky. The sun is in the sky, and we can see the sun, so we could see at least 3,000 miles if that's how far away it is.
Right. And the size becomes a lot smaller. It's not as big as...
size is an interesting thing about the sun. So, one very interesting thing about the size of the sun is that it doesn't change throughout the day. You can measure the sun's angular size as it rises in the morning, and it will stay within 0.1% of that angular size throughout the entire day. Now, if the sun was 3,000 miles above us, that would mean that the sun's angular size, as it moves, past us and away from us on a flat Earth, would shrink by 3 times. So as the sun was setting, the sun would have to be a lot smaller than it is, say, in midday. But it's not. The angular size of the sun stays exactly the same. And the way that we can explain that is that the sun is extremely big and very far away. Do you see how, reality of the situation, the reality of what the sun doesn't match a hypothesis of it being a small and local sun, simply through the fact that it doesn't change size throughout the day?
That could possibly be the oscillation.
Oscillation?
I think there's an oscillation between the sun and the moon, like an up and down wave movement, up and down, and revolving around us.
Well, we don't see the sun having a wave type movement, do we?
A diameter of 32 miles, both.
Right. I mean, those are very specific figures, and we would be able to do things like track its angular size. And whether or not it is moving up and down slightly wouldn't actually, again, even if it is moving up and down, if it has a wave type function like you say, then that would change the angular size of it even more throughout the day. But what we see in reality with our eyes is that the sun stays the same size in the sky from sunrise until sunset. The angular size stays exactly the same, which is impossible if it's orbiting above us and it's only 3,000 miles. The angular size would change significantly.
It's just depending on how far you're able to see it in clarity.
Well, there's been times when you can see it throughout the entire day.
We're standing on the ground looking at it. So when we look up, that's all we see. we don't see anything else, especially when we look straight up. But when we're looking down towards the horizon at the sunset, we're seeing through all the pollution. That's why we have the red color. And so refraction of white light going through the clouds is making the bottom of the clouds look orange.
Okay.
This is back to your point in your picture. So you're looking directly at those rays that look like they're coming up. But if you were to be north in that picture, if you were farther north looking at that same image, it wouldn't.
So
it wouldn't be. It wouldn't be the same. Those rays would be coming down to the ground still.
What I'm showing you is from a friend of mine, Red's Rhetoric, where he took pictures of the sun throughout the entire day using a P900, I believe, and he had a solar filter on the camera to remove any unnecessary glare. And as you can see, throughout the entire day, the sun doesn't change in angular size, which is a big point. The fact that the sun doesn't change in angular size means that it can't be small and local, because it was. But throughout the entire day, from sunrise to sunset, every single picture he took had exactly the same angular size of the sun. Let me do a little run through here. You see it side by side. This disproves the notion of the sun being small and local, simply because it doesn't change in angular size. There is no atmospheric refraction conditions, no sinusoidal wave function that could cause the angular size to be exactly the same every single time that we measure it. No matter what day it is, no matter what time of year, we can always measure the angular size to be the same throughout the day. Which, like I said, disproves the notion of a small and local sun, and shows that crepuscular rays are simply a matter of perspective.
That's all I can agree with, is that it's a matter of perspective.
And there's actually a formula for perspective where you can see these things, okay? The formula for, angular size perspective is alpha equals 2 times the arctan of g over 2r, where alpha is the angular size of the object, g is the distance to the object, and r is the actual size of the object. And using that formula, you can calculate how big things should be based on how far away they are. And if you apply that formula to reality, it disagrees with the notion of a sun being small and local. Do you understand?
I got you.
Okay, right.
I got you.
Now, let's move on to the next bit then, because the next bit you said was about water being level.
Yes.
Yeah.
Water always finds its level.
What do you think that means?
It's the visible settling of water. I mean, that's where everything else goes to find its lower spot.
Yeah, and why does water do that?
That's where it's collected.
Yeah, but I mean, what physical mechanism, what force, what acceleration, what is causing water to find its lowest point of potential energy?
There would have to be terrain. The terrain leads downward.
Well, yeah, I agree. Terrain leads downwards. Like all rivers flow downwards, towards the seas. But what is causing the water to do that? Why is it trying to find its lowest point of potential energy? There has to be a force acting on something, right, to make it move.
Oh, water in its densest form is going to run down. It's going to collect all together. If it's touching, it's going to collect.
Yeah, but why?
Because that's That's the elemental makeup of it. It connects itself.
Okay, so what you're saying is that water just has some inbuilt property to collect together.
Oh yeah, it's a part of the system.
Well, why
Of
does, for
all the
instance, a
elements.
raindrop fall?
I mean, how deep you want to go? I mean, it's a part of the elements, and it's a part of the function
Well,
of
water isn't an element.
extraction.
It's a
It's an
molecule.
extraction. It's an extraction from the earth through sun rays. That's what we have evaporation for. And then
Right,
when it
but my
collects,
point my
it
point
drops. I
is
mean,
my question is that what is causing that water to want to find a low point? Why would one? Just let's concentrate
what
on one drop of water, right?
what
One drop of water
what
falls out the sky, hits the top of a mountain, into a lake. That lake leads to a river. Why is that drop of water wanting to go down and find its lowest point? What's making it do that?
it's dense in its form.
I don't understand. It's dense. How does that make it move?
It's like it's a continual thing. I mean, it's just there. Like that's something that just it happens
Yeah.
through the sun
Do you
rays. I
know
mean,
why
you
it
get what I'm saying?
happens?
Like
So here's an
so. I
important thing
mean,
about water and, well, everything really, that it reacts to forces applied to it. Newton's first law: an object in motion stays in motion unless acted upon by an unbalanced force, right? That applies to water as well. So water can't just move on its own for no reason. There has to be some kind of
but
unbalanced force being
but
applied to
but
water.
but we know that sun rays cause evaporation.
Yeah,
So
because it heats up
water
the
is
water.
let's but I'm saying let's discuss it though. If the sun is shining down on the earth, causing green grass and all this stuff, it's doing it by water, hydrogen. So hydrogen is the main thing circulating in the whole system.
Sorry, are you saying
And
water's
when it
just made
couples
of
with
hydrogen?
everything, that's what's movement. Excuse me?
Did you say that water's just made of hydrogen?
No, I said it's circulating. Hydrogen is the most abundant atom in the whole universe. So
Correct. It is. You're right.
I'm saying it's the movement of it in everything, no matter what it is. So I'm just saying, what are we getting at with the circulation of it?
Yeah, but
It's
what's making
circulating.
it?
It's the
What's
most
making it
abundant
move?
thing.
What makes it go from one point of the circulation to the other? There has to be. Let's go back to Newton's law again. Newton's law says that an object in motion with a direction and a vector will stay in that motion unless acted on by an unbalanced force. So let's look at a molecule of water that's, say, falling from a rain cloud. Why is that particular molecule of water heading towards the ground? What is the unbalanced force that's being applied to that to change its state of motion?
It's still sun rays,
Sun rays aren't a force of any kind.
but we know the sun gives off various different lights, and those lights are frequencies, right?
Yeah, but okay, rain happens at night as well.
Okay, but the
So
sun is still shining somewhere.
yeah, so the answer to your question, well, to my question, is gravity. All right, gravity is the reason that
There
water
we go.
will find its level on Earth. If there isn't any forces being applied, then water actually doesn't do anything. There's videos of them using water for experiments in space and showing that water will literally just form a sphere and stay there, not doing anything, unless there's another force applied to it. Gravity, in this case, imparts that force. Gravity is the reason why water will seek to find its lowest point of potential energy.
Maybe so, but it's still a dense thing. It's more dense
Yeah.
than air, so it's gonna drop.
So how does water being level, how does water finding its lowest point of potential energy show that the Earth is flat? Because gravity is the reason that it's doing
Because
it, and we know that gravity just pulls everything towards the center of mass, which explains why
because
water on Earth finds its level.
because all water on the earth is touching, right? No matter where you go, they have the seas divided, but seas are touching seas
Yeah, yeah,
somewhere. If
correct.
you know what I'm saying. So,
We can agree that
so
all the
what?
oceans and seas are connected,
Right,
mostly.
and so there's different sections of the earth that have different types of water. Where you have that one divided water that looks one is brown and one looks kind of dark bluish. And so there's waters that won't even cross each other due to the makeup. So regardless of all
But
of that, the water it is level everywhere. You say sea level, all of those places are the
yeah,
same height
okay.
out of the water.
Ah, I see
They're,
the issue.
they're
I see
all
the
the
issue.
same height out of the water.
When we're talking about the shape of the Earth, what do you think the word level means?
I mean, straight across,
No,
straight across.
that's the issue here. The word level, when we're talking specifically about the shape of the Earth, means curved. In fact, the dictionary definition from the Merriam-Webster dictionary is having no part higher than another, conforming to the curvature of the liquid parts of Earth's surface. So level, in this case, and according to surveyors that use level as a term, level actually means curved. So when you say water finds its level, you are correct, but level conforms to the curvature of Earth.
So, what strength does gnats and and flying insects have against gravity?
Well, they've got wings, don't they?
Why is anything that has any density got to have a force to hold it down? Like, why isn't the weight of a thing just the weight of the thing and not being
Well, weight is a
uh,
function of gravity itself. Did you know that?
if we're talking about a flat Earth, why does anything need to have a force to hold it down if we're like on the bottom? We're
Because as
we're
Newton's law states, an object in motion stays in motion unless acted on by an unbalanced force. Things don't just move for no reason. They have to have something happening to them to change their direction, to start moving, to accelerate. They don't just do it on their own. There's the natural laws of the universe were described by Newton and tell us how the universe works. And the universe works by things having forces making them move. So that's why we know that gravity can impart a force and keep things to the ground. Now, you asked why a insect can overcome gravity. Well, that's very simple. An insect's mass is very small, and they have wings, which means because the mass is small, there isn't much of a gravitational force, and their wings can create a force in the opposite direction to gravity. Water, of course, does not have wings. So there's no way that water can create a force to go in the opposite direction of gravity, which is why it stays at its level.
okay. But if we're at the bottom of a thing, if we're on the ground and I'm 165 pounds, that's me on the ground. Why does anything have to be holding me down, invisible to me and everybody else,
Okay,
to the
so
ground? Why isn't it not my way?
what happens when you stand on a scale?
My weight pushes it down.
Yeah, so that shows that there's always something pushing down, right? And you're right, it's your
my
weight,
mass.
but
Why?
weight
Why
itself
is it
is
not
a
my?
function of gravity. Weight is described as mass. So if you're 165 pounds, whatever that is in kilograms is your mass, right? And weight is your mass times the acceleration of gravity. So when you step on a scale and the scale shows a number, that's because there's a force being imparted, pushing you down, that is giving a force proportional to your own mass. And there's counter forces coming from the earth pushing up, which is why the weight, the scale itself, shows a number. And the fact that when you stand on a scale, it should, it registers that there is a force acting upon it, shows that your mass creates a force, which is what we call gravity.
What vacuum then? When does the vacuum start?
What vacuum?
The vacuum of space.
So space isn't actually a vacuum. Space is a... Sorry, go
on. I'm just saying, at what point does a vacuum start?
Well, again, space itself isn't a vacuum, right? Space can be described as a very low pressure system, a near vacuum, but it's not a vacuum. And there isn't a point where you just go from having pressure to having no pressure. What we experience on Earth is a gradient of pressure. So if you're at the bottom of Everest, you're going to be experiencing about 14.7 psi acting upon you. But if you climb to the top of Everest, it's actually more like 4 or 5 psi, showing that during your ascent to the summit of Everest, the pressure around you has dropped dramatically. In fact, there's more of a difference in pressure between the base and the summit of Everest than there is the summit of Everest and what is considered space. Now, if you're at the summit of Everest and you're at like 4 or 5 psi, keep going up, and that psi keeps dropping and dropping and dropping and dropping until you get to a point where it's such a low pressure it can be considered a near vacuum. And that's it. That's all that happens. There's a gradient of pressure that gets lower and lower and lower the higher you get, which is again a function of gravity.
This is something that I partially discussed the other day, that the higher you get, the less pressure. And it would be just, it's like the same with a dense fluid. The deeper you go into the sea, the more pressure because of the weight of the sea.
Yeah, again, a function of gravity, yes.
That's understood. But I'm saying, why do you feel like the Earth has to be a ball for water and all the things that are less dense than what is in the air from the ground up? Why does anything have to be pulling us down? That's the change of thought process in the flat Earth. Is like we don't need gravity.
And that's the problem, is that flat earthers don't understand the basic physics behind the way the universe works. We have to have something making things move. Things don't just move on their own. Newton's laws tell us this, especially Newton's first law. And that's why we know that there's an acceleration making things happen, and that acceleration is a result of gravity. You can't have a force without the acceleration. So we know that there's a force acting because we can measure the acceleration and we can calculate where it is. And here's an interesting thing about gravity. It's not the same everywhere on Earth. In fact, at the poles, you weigh about 0.5% more than you do at the equator, right? And there's two reasons for that. Number one, at the equator, there's a higher tangential velocity, so a higher centrifugal force acting in the opposite direction to gravity. And also the poles are slightly closer to the center of the Earth, which means that there's a stronger gravitational force because you're closer and you're not having a counterforce in the centrifugal acceleration. So you weigh more at the poles than you do at the equator because gravity varies based on where you are on Earth. Density can't explain any of that.
Why would you think that it was still a theory, though?
Gravity is not a theory.
That's the best explanation of it. But they still can't figure out gravity.
We got gravity pretty well figured out
in its form in that study of it. For that study of it, it's still in theory.
When you say that gravity isn't figured out, what do you mean?
Why does anything have to be pulling us down or pushing us down besides us being a dense form?
Because density isn't a force. Density is a scalar.
It doesn't have to be a force. It's just an accumulation of mass.
Well, yeah, but
We're
as
just an
Newton,
accumulation of mass and structure. We're
yeah,
structure
but again, as
of
Newton's
bones.
first law tells us, we need a force to make things move. And the fact that when you get on a weight on a scale and it shows a number shows that that force is still there even when we're at rest on the floor. You know, that's why your arms feel heavy. That's why, as I'm a fat bastard, I've got more of a weight, you know, because gravity is a thing that can be measured pretty easily. And density simply cannot make things move for no reason. Density is one of the variables in the buoyancy equation explaining why things act in the opposite directions to gravity. But you can't have any of this movement. You can't have the weight on a scale. You can't have any of that without gravity.
Okay. This is one of those kind of mute points sometimes.
Okay, right, okay. I would seriously suggest looking into gravity. I can send you some links to... There's an entire industry that uses gravity to measure things underground to find dense materials like oil and minerals and stuff, right? I can send you all the studies on that. But let's move on to the next thing you said, which was that you can zoom boats back in when they've gone over the horizon. Was that right?
Yes.
Could you elaborate on that for me, please?
It just, whatever number, we're just going to use any number. So let's say, well, let's just use the equation. They say that the curve of the Earth, to get the curve, is 8 inches per mile squared. So for every mile,
who says that?
You dropped it. This is the equation that they use.
Sorry,
the Earth.
Who would use that to determine the curvature of the Earth?
Just in discussion, it's always the globe users and flat Earth users.
So there's a problem with that measurement, with that equation, with that function, is that unless you're using chord measurements, which doesn't really make sense, it doesn't describe a curve, it describes a parabola. And I did a bit of research into where that particular number came from, why it became part of the discussion. And what I found was that the OG flat earther, Samuel Rowbotham, misread a surveyor's book on leveling, right? And when they were talking about leveling over short distances, they had that equation to roughly describe what was going on over a very short distance. And Samuel Rowbotham, being a flat earther, simply ran with that and said, oh, the globe says that it has to be 8 inches per mile squared, and that is the firm geometry, and we have to have that, where it's actually incorrect. The further you go, using that as a standard drop measurement becomes more and more, less and less accurate the further you go. The correct equation to use would be H equals 1 times A minus cos A. Sorry, no, that's right. H equals R times 1 minus cos A. Right, that's the correct equation to use for on a sphere of any size, calculating what the hidden amount of something should be. 8 inches per mile squared simply doesn't describe what we need it to describe with what we're talking about.
Okay, so whichever. That's one of the discussions that the flat earthers have too, is which one do you want to use, and let's run with it.
Okay, so anyway, this was about boats going over the horizon, right? And you said that boats can be zoomed. Did you say that you could zoom boats back in once they're gone?
Yes, if we use those equations for the drop and the curve, because like I said earlier, like we were talking about earlier, all the water that's touching is on the same level plane, regardless if we're going to say it's a sphere or if it's flat. No matter if they touch that are on the different geographical areas of the Earth, and they touch, they're all level across the same. That's right, what we're saying. And
let me show you this video. This is from someone I know called Dazza the cameraman. and I think he's in Australia somewhere using a P1000. And you've got these 3 ships on the horizon. You can just see one there, one here, and one there. And what he does is test the theory that you can zoom things back in. So if you could zoom things back in, you'd be able to bring the entirety of these 3 ships back. So what he does is he zooms in a bit and takes a screenshot, right? Let's get to the point where he takes a screenshot. So he zooms in and he takes a screenshot here of this ship on the left, which, as we can see, appears to be partially hidden by the horizon. And he continues to zoom in. And then compares the two. So on the bottom, we can see the screenshot that was taken when it was zoomed out. And then as he zoomed in, is what you see at the top. And this quite clearly demonstrates that no amount of zooming in will change the visible amount of something that has been hidden from the bottom up by going past the horizon. What do you think of that?
What is the equation that they're using, and how far is those distances?
Like I said, the equation would be h equals r times 1 minus cos a, and pretty sure he's got the distances of those ships in here. Description. So the distance sinking ship, that one there is 12.6 miles. The closer ship, this one is 8.6 miles away. But the distance is kind of irrelevant to the fact that we can clearly see that part of the ship is hidden. And we know that ship wasn't sinking. So how do we explain that the bottom of the ship is hidden and that zooming in didn't bring any of it back?
It still had a vanishing point, and you could see the mirage in between it and the bottom.
There's no mirage in there. None at all. And vanishing point doesn't explain things disappearing from the bottom up. If anything, as things get further away, they reduce in angular size in totality, not from the bottom. What we need from the flat Earth is an explanation of where the bottom of this ship is and why zooming in didn't make more of it appear.
He couldn't zoom in far enough.
But no, he did zoom in, and as you can see, the zooming in didn't change anything. So no matter how far you zoom in, it's not going to change it.
Okay, so at 12 miles, how far down said the Earth had dropped?
I mean, it's irrelevant because refraction would be happening here. Clearly, everywhere, everything's refraction.
Those are physical stacks. There's not, refraction would cause mirage.
No, but refraction can change the apparent distance of things. Refraction can make the horizon appear further away than it should be. That's literally what refraction does, especially in a gradiated atmosphere that's curved. It would naturally make the horizon appear further away than it actually is on the majority of occasions. And that's based on subject matter expert Andrew Thomas Young.
But we're still trying to factor out vanishing point. You can't do that.
Again, vanishing point doesn't explain where the bottom of that ship is. A vanishing point, if there was such a thing, would have things disappear in totality. So the bottom of the ship wouldn't disappear. But the entire thing would shrink together.
How many miles away from it is that bigger ship?
The bigger ship is 8.6 miles away. In the middle. Yeah, the one in the middle is 8.6 miles away. The one slightly hidden by the horizon is 12.6 miles away.
Yeah, that's, what, 4 more miles?
Yeah.
You still got 4 more miles to zoom in.
You don't zoom in over miles. That's not how zooming in works. I mean, zooming in, all zooming in does is change the apparent angular size of what you're seeing. All right?
Okay, but from our perspective, and him 12 miles out and that one 8 miles out, what is the curvature drop? How much did that ship drop in the back?
I
At 12
don't know
miles?
the exact mass, but again, using the curvature calculation is irrelevant in this situation because you're looking out over water, which has the highest refractive conditions. So you will not be seeing the geometric position of these ships or the horizon. What you'll be seeing is a refracted apparent position of both of these things. But there's still a horizon with something clearly beyond the horizon. No amount of zooming in will bring the bottom of that ship back up, because zooming in doesn't change the position of things, it simply changes the angular size of things. So again, I have to ask from a flat Earth, where is the bottom of that ship?
I don't think that the camera can go in as far as it needed to go to determine that.
But the camera,
Mike, that's why I say calculate what the real drop is supposed to be.
again,
so from 12 miles out, how far down is it supposed to be?
Again, doing those
You
calculations based.
How tall is the ship? How tall is the ship? And then how tall is the drop supposed to be?
So Ben,
on the calculation that's official.
Ben,
if the calculation is official, let's work the calculation and get how far that ship is supposed to be dropped, and we can say that, hey, that's the spear.
So Ben, again, what you would see in any instance when you're looking at oversea would not match the official calculations, because refraction needs to be taken into account. If you do just the calculations based on a geometric sphere, you're not going to get matching what you see in reality, because we're looking through an atmosphere which has refractive conditions. And like I explained to you just now, refractive conditions on Earth tend to move the horizon further away, allowing you to see things further away than they are. But that's all irrelevant to this point. The point is, where is the bottom of that ship? Because zooming in doesn't bring things above or below the horizon. It makes the angular size bigger. No amount of zooming in will bring the bottom 2/3 of that ship back above the horizon, because that's not what zooming in does.
You're still standing at a 5 foot to 6 foot stance.
So where's the bottom of that ship?
Over the sea. So the horizon is still going to be where it's at, no matter that. But if your telescope can zoom in past what your vision can see, you should be able to see that.
You still wouldn't be able to see the bottom.
If his camera lens would have went in farther, you would have seen the bottom.
No, but as you can see, between these two zooming ins, no extra ship appeared. The same amount of ship is there. So let me ask you this question. At what point during zooming in does more of the ship start appearing? Because as he zoomed in this case, as he zoomed in, you can actually see him zooming in. It doesn't make a difference. So if more zooming in would cause the bottom of the ship to appear, then just a little bit of zooming in would cause at least some of the ship to appear, but it doesn't. No matter how much he zooms in, the exact same amount of the ship is visible. So at what point does it randomly start showing more of the ship?
I say it's in the power of the telescope.
Yeah. If telescopes don't make things
but that line right there is what you call the horizon, only because there's a ship right there. And
no, ships don't define what the horizon is.
I'm saying that the water is level.
Yeah, correct. And level means conforming to the curvature of Earth.
And the vanishing point up to, as far as we can see, is the horizon line. That is the horizon line to us, because that's the sea.
Yeah, so okay, but none of that explains where the bottom of the boat is.
You're still trying to get 5 or 6 to 7 feet worth of vision off the ground to see past the vanishing point. You can't do it unless you're...
Yeah, okay, so if the Earth... Here's another thing. If the Earth is flat, then changing elevation won't allow you to see any further.
Changing elevation hasn't shown that the sky gets bigger.
Yeah, I mean, it's irrelevant to the conversation we're having right now. But my point here is that zooming in did not make any of that ship reappear. And you've got quite a good view of that ship there. It's not like it's really small in the viewfinder. Most of that ship is you can see the entire length of it. But half, more than half of it, 2/3 of it is under the apparent horizon. There is no amount of zooming in that will cause that to pop back up above the horizon, because in between this shot and this shot, it doesn't appear anymore. If zooming in caused more of it to appear, there would be a difference in the amount visible between these two shots, and there isn't, which debunks your claim. Now, I did a little thing to kind of try and explain how angular size and stuff works, right? So let me quickly show you this. So this is me in my kitchen using some of my kids' blocks, and what I've done is I've made sure the camera is level with the table, and the table's pretty much completely level. And I've put these blocks, which are all the same size, at different points along the table, and I've drawn a reference line that would be considered the vanishing point, right? And what we see is that as I move this block in particular back, let me speed this up. As I put these blocks along, showing you that even though they're the same size and they reduce in angular size, the top of it doesn't disappear, which would be, the same as your claim as the bottom of the boat's disappearing, because that yellow line would be considered the horizon, the vanishing point, but just, the other way around. So all that happens is that these blocks reduce in angular size. Even though they're the same size, it appears smaller, but it reduces in size in totality. That blue one, right, that you can see, is the same size as that green one. But in totality, the angular size appears to have shrunk. And to further demonstrate this, what I do is I move some of them out of the way, and I take this one and I just move it backwards. And as you can see, as it moves backwards, it doesn't go above that vanishing line. It doesn't, part of it doesn't disappear, the top of it doesn't disappear. The whole thing reduces in size in totality and always stays relative to that reference line that I've put there. Showing that no matter how close things are, all that changes is the apparent angular size. How'd you feel about that?
Push the table down a little further and keep going and see if it crosses that line ever.
Well, it didn't move it at all that far, so why would it randomly start doing it?
No, I'm just saying, you have more table you can use. Scoot the table down and see if it goes even further.
I mean, that's as big
or
as the table goes.
Like that line.
But there, at no point on that table did it move. So why would adding extra distance change what's happened? Why would adding extra distance change what's happened in relation to that that line?
So we can see how far out it goes. If that's a straight line, then we're going to watch it be parallel in our vision. Our vision
and,
is that,
as it shows,
line.
As it shows, the entire thing reduces in size in totality, right? The entire thing. And that doesn't match what we saw on the video that I was showing you, does it? Right? Let me bring that back up.
I'm saying on the closer side of the table, you have a lot more table to use. Scoot the table down some more and get it past the line and see what it looks like.
I don't have any more. I've used the entire table, literally, right? But my point here is that when you compare the two realities, it doesn't match. Because in this picture, part of it's missing, right? Even though the angular size is the same, part of it's missing. But when we look at this one, nothing's missing. Right? This is what you would expect to happen on a flat Earth. You would expect, as things got further away, for them to reduce in angular size, not disappear top or bottom for no reason. What we see on Earth is that things disappear from the bottom up as they go past the horizon. And there's only one logical explanation for that, for only the bottoms disappearing first, and that is that they're going over an effect of the curve of the Earth.
You added the yellow line.
Yeah, in this one I did, yes.
So
that's the same as saying that's the horizon.
So you still have more land. You're stopping the horizon.
And it's showing you that no matter how far away the horizon is, the only thing that changes is the angular size in totality. If the flat Earth theory was correct and the vanishing point makes the bottom disappear randomly, then in the same way it should make the top disappear randomly. But it doesn't. All of it stays there. The entire thing stays there. The only thing that changes is the angular size. But when we look at the reality of a boat going beyond the horizon, part of the boat misses. It doesn't just change in totality for angular size. Part of the entire boat disappears. These two things don't match. So only one of them can be true for the reality of Earth. And that's this one that we see when we look out at the horizon and see boats going over it. It's an effect of the curve of the Earth. That's what the horizon is. The horizon is an effect of the Earth having a curve. Right? If the Earth wasn't curved, there would be no horizon. And I'm going to say this specifically for you, hip hop hippie, as I know you're watching this, Bumpy Earth 420, whatever your name is. The horizon is an effect of the curve of the Earth. No curve, no horizon.
So you might have to get something to eat today.
So
It's
what's your
still
thoughts on that?
perspective. Well, I mean, just looking at your diagram, you're putting a line at the top of that. So where's the line for the top of the ships?
Well, I'm just giving an artificial horizon. All I'm doing is saying, well, this would be the vanishing point because that's what's eye level. You know, that's where the top of all those things meet. So in relation to flat Earth, that would be what you guys call the vanishing point. But what I've shown with my picture, with my video that I made, is that the vanishing point doesn't make random parts of things disappear. What the vanishing point does is have things shrink into it in angular size in totality. Not just a part of it randomly disappearing, the entire thing all at once. The only way you can get part of it missing is if there's, curvature causing an effect like the horizon. Boom. So that explains why boats going over the horizon kind of debunks the flat Earth and shows that you can't zoom things back in to show the bottom of it. It's just not possible. So should we move on to the next point, which I think was the ice wall?
Yeah.
Right. So there's no ice wall. I've been to Antarctica. I've been to McMurdo Station, and there's no ice wall. There was a bar, a really good bar, but there was no ice wall. How does that? Why didn't I see an ice wall when I went there?
It depends on what your reference of an ice wall is. I don't.
What do you think an ice wall is?
I think what they call the ice wall is just a mass of land that's ice, or is frozen at the moment.
Okay, and your claim is that and your claim is that the ice surrounds the entire Earth like a ring, yeah?
Yes, and it goes further out than what they tell us.
So would you say that this kind of represents what you're saying with the ice all around the outside?
Right.
Right. So here's the thing. There is a bi-yearly yacht race that goes around Antarctica. Anyone can enter. It's not a secret or anything. Anybody can enter this yacht race that sails around Antarctica. And when they do it, they generally measure the distance that they go to be between 14,000 and 16,000 nautical miles, right? That's what they actually measure when these people, do the race every other year. Now, 14. Remember that figure, 14 to 16,000 miles. Now, if the Earth was like this, with a ring of ice around the outside, that would mean that circumnavigating that ring of ice would actually equate to between 40 and 45,000 miles, which isn't what we experience in reality. In reality, when that race is done, when they measure how far they're going, they only measure between 14 and 16,000. And they go around Antarctica, the entire thing. So how do you explain that discrepancy?
Let me see. I've seen a different map. Well, it was like that one. I guess I can say that. It was like that one, and it had the whole race mapped out. It had like 2 or 3 races mapped out on that map, and with all their distances. I think you just have to look up I think it's like the Magellan's race or something like that.
Yeah, well, like I said, the actual race that is done around Antarctica bi-yearly, anyone can enter, and you can follow it, and they don't go between 40 and 45,000 miles. Kilometers. They only go 14 to 16,000 nautical miles. Sorry, nautical miles, not kilometers. But that's impossible.
I'm saying the map that I'm talking about has 2 charts mapped out on it. One is like red and purple, and one is those numbers. It has those numbers on it. The ones that you're rejecting, it has those numbers on it, mapped on it.
I mean, I've done a lot of research in this, and the only yacht race that I find that's done regularly is the bi-yearly one that has a recorded distance of between 14 and 16,000 nautical miles, not 40 to 45,000 nautical miles, which is what you would need for a ring around the outside. That would be an absolute necessity for that to happen.
And I'm saying, I think that somebody has navigated that. There's, like I said, the map that I seen that looks like yours.
My research disagrees.
The whole thing mapped out.
I've done a lot of research on that, and I have not found any race that goes around Antarctica that says that it's 40 odd thousand nautical miles. I've done extensive research on that.
I don't think I ever mentioned a race. I'm just saying that it's mapped out on that.
Yeah,
there's something mapped out. Somebody mapped something out, mapped a circumnavigation out on it. There's like 2 or 3 of them, and then it shows the different Antarctic bases and a bunch of different descriptions of whatever we would see on the spherical Earth. Those spots are mapped out also on that map.
I mean, I don't know what you're talking about. I've never seen it, so I'd have to have a look at what specifically you're referring to before I can really respond to that. But what I'm telling you in reality is that when they do the race, when they map the the distances that they go, and this isn't like a super secret, only government can enter. This is literally anyone can go and enter this race, and when they do it, they measure the distance they travel between 14 and 16,000 nautical miles, which doesn't equate to a ring around the outside of Earth, which would be at least 40,000 miles.
Well, I'm saying that might be on that map as well.
I mean, I'd need to see what you're talking about, really, but the yacht race itself debunks the notion of there being a ring around the outside, because they don't travel far enough to do that. They simply don't. And you can track the entire thing of each ship by GPS and everything. So there simply isn't a wall of ice or a land of ice surrounding us. Antarctica is a continent on the south of Earth. It's as simple as that. And there's a bunch of penguins there, not much else. Really, not much else. A lot of ice. Some sea lions, I think. Maybe some walrus, but it's pretty cold and the biggest desert on Earth.
Let's see.
Um,
I was trying to look for the map, but I would have to do it. I'm on my phone, and I don't.
yeah, well, if you could maybe send me that another time, I can have a look at what you're talking about. But my argument is simply that the yacht race debunks the notion of a ring of ice around the outside. So
yeah, I don't have anything for that because
okay, now,
of what I kind of adhere to. I don't know
so
if people can see this, but have you seen this map?
yes, I have seen that, and it's hilarious. I mean, there's no way anyone could ever have mapped that. That's literally a fairy tale.
It possibly is.
Yeah,
but
definitely is.
why is it being circulated just as interesting as the globe Earth? Everybody knows the globe Earth. I used to be a globe earther. Like, I understand all the inner workings and stuff. All that you were talking about earlier.
Really?
I mean,
okay, well, let's. Why
of,
don't we move to some evidence or that I can show of the Earth being a globe that rotates? How about that? And we can have a little discussion on that.
Sure.
So, my main argument that I always go to is that we can measure the rotation of the Earth in 3 axes. All right? We can, if the Earth is a rotating sphere, then there's certain physical forces that will be imparted, and we can measure those, and they're quite easily measurable. I'm going to start with the famous one. Get the emojis ready, guys. Oh, and I've got no bloody sound on them. One sec. Why is Bob not saying anything?
It's going to drift.
Right, here we go.
If the Earth is spinning at 1 rotation every 24 hours, that means that every hour it has to turn 15 degrees. And if the gyroscope is mounted anywhere on Earth, it's going to drift. In today's 21st century navigation systems, they're using what's called a ring laser gyroscope. It is extremely precise. If we could simply get one of these ring laser gyroscopes, we would be able to prove once and for all that there is no rotation to the Earth. One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up a drift, a 15-degree-per-hour drift.
Thanks, Bob. Thanks very much for that. So that's famous flat earther Bob Nadell using a fiber optic interferometric gyroscope to literally measure the rotation of the Earth as predicted. And the instrument that he used, the gyroscope, there's millions of them all around the world. Every plane has 3, measure yaw, pitch, and roll. Some of them in drones. You know, they exist everywhere, and they all measure the same thing, right? They measure that 15-degree drift in 3 axes, yaw, pitch, and roll. And not only do they measure a 15.04 degree per hour drift, but they also measure a roughly 1 degree per day drift in 2 dimensions. That represents Earth's orbit around the sun. So with the same device, we can measure both the rotation of the Earth around its own axis and the rotation of the orbit of Earth around our star. Easily measurable.
What are the axis points for its movement in the gyroscope that you said?
Well, it meant, like I said, that the gyroscope that I just showed you.
From what source is it? You know what I'm saying? Like,
well, it's using the Sagnac effect to measure the rotation of the Earth by interference in light wave patterns.
So what light wave has to be entered into it? From where?
Let me bring up. Give me 1 second. Right, so this is a very basic description of how a fiber optic gyroscope works. It kind of just shows it in 2 dimensions, but gives you the idea. Let me just zoom in on that so everyone can see it. Right, so this blue box that you see fires a laser or a coherent light source. This diagonal line is a mirror that splits the beam into 2 paths. Right? Now, if the device itself isn't moving, as the beams of light go around the circuit, they recombine. Right? And because, c, the speed of light, is constant, they're going to take the same amount of time to go around this path either way, and they're going to recombine, and there's going to be no interference. All right? There's going to be no deconstructive interference of any kind, which would indicate that the device itself is stationary. However, if the device itself is moving, what that does is physically change the distance that one of the beams of light has to travel. In this case, because it's going clockwise, the red beam of light has had to travel a shorter path because the gyroscope is moving underneath the movement of the light, which means that the red path has been shorter. And what that measures as is an interference pattern in the light wave. So as the red light goes in, you get one waveform, and then as the blue one goes in, you get another waveform. And because they're not synced, that measures as an interference pattern, right? And you only get that interference pattern if the entire thing is moving. That's the only way that would happen. It can't measure outside. It doesn't know what's going on. The only way that you will measure an interference pattern in the recombination of the light is if the entire gyroscope is moving, which is what Bob did.
One rotation every 20.
Sorry, I'm just going to mute him a second. Bob. There. So, and that's what Bob did. They used this interferometric fiber optic gyroscope to measure if the ground that they put it on was actually moving. Now, if the Earth was stationary, then, as my display showed, the interference pattern would be practically non-existent. Well, because it's not moving. As they recombine, there's going to be no interference, and it's not going to register as a drift. But because Bob actually measured the drift with it, there it is, that's the inner workings. As Bob measured the drift, a 15.04 degree per hour drift, what that shows is that the entire apparatus itself is moving, changing the distance the light has to travel, registering as an interference. And it registers it in 3 dimensions, with the yaw, the pitch, and the roll, showing that the Earth rotates 15.04 degrees per hour in 3 axes, which is only possible if the Earth is a globe. Thoughts?
So the light movement had no restrictions at all.
No, not at all. It's in a vacuum, basically.
Yeah, I mean, I have nothing like that. Yeah. That just goes into something else that would have to be considered, even if it was,
what would be an alternative explanation for the interference pattern?
I mean, it may be just light trying to travel through another medium.
But the medium doesn't change. The medium inside the gyroscope never changes.
That doesn't, but that was you're trying to measure is bouncing around.
Yeah, for a straight line path. I mean, obviously, everything moves within its own reference. There is no absolute motion. Everything has a reference frame. And for the light, the only reference it has is the distance of the path that it has to travel. And if the path is physically moving underneath it, because, the light's been fired, but the gyroscope is rotating with the Earth, then the light can only react to that. That's the only thing that is affecting how far the light is having to go. And the thing is that it matches up with other measurements and experiments as well, quite easily. For instance, this is a gentleman called the gentleman physicist, okay? And he's using the concept of Foucault's pendulum to try and measure the rotation of the Earth. Obviously, Foucault's pendulum set is something invented by French physicist Léon Foucault. It was one of the very first measurements of the rotation of the Earth. Obviously, if the Earth is rotating, then a freely swinging pendulum will have a Coriolis force applied to it because it's a freely moving object on a pivot point with the Earth rotating underneath it, the Earth rotating independently, right? So he made his own Foucault's pendulum to test this. And the interesting thing about the Foucault's pendulum is it drifts a different amount based on where you are on the Earth, because the forces in part will be slightly different depending on where you are. And they used that in this experiment. So what they did was they had this swing back and forwards. Simple pendulum, swinging backwards and forwards, and it's got this little ink pot and a brush to show the path of the pendulum, right? Now, if the Earth is rotating, what we would expect to happen is, as this is swinging backwards and forwards, that the straight line path would drift, because the Earth is rotating independently to the straight line swinging path of the pendulum. If you're in the northern hemisphere, you'd expect it to go clockwise. The closer you are to the poles, the more it would drift. So they let it swing as long as they could. I think it was about 45 minutes, 41 minutes, 0.65 of an hour. And as you can see, the pendulum has drifted off of the straight line path, right? And they were able to measure an angle of that drift. So as they show here, they measure the amount of change in the straight line path. Clockwise turn means they're in the northern hemisphere. And the angle that they got was 7.89 degrees, right? So that is how much the pendulum has drifted off of its straight line backwards and forwards path. So what can we do with that angle? Well, we can do a bit of maths, basically. First of all, we know the final time was 0.688 hours, so we can calculate what it would be during an hour. And then we can find t, which is the total time it took to do what it's doing. And I think he's left during my explanation. Is he going to come back? I think he's gone. Oh, there you are. You back?
I'm back.
Right.
Sorry.
Where did we get to?
Sorry, I had my phone was plugged in, but I guess it wasn't charging.
All right. Okay.
So
No
it
worries.
died, so I had to back up.
Right. So I was saying about how when the pendulum is swinging on its straight line path, it induces a drift into the straight line path, and they measure the drift as 7.89 degrees. Then they can use that to actually calculate their latitude on the Earth. Simple bit of maths here. The time taken is that amount of the hour over 360 divided by the angle gives you one full rotation in 31.4 hours. That would be the period of rotation of the pendulum based on what they measured. So you can use the formula for latitude, which is arc sine, and then 24 hours divided by the period of rotation. And that will give you your latitude on the Earth. So based on the experiment they did, they took the measurements and they calculated their latitude on Earth should be 49.8, right? And what actually is their latitude? It's pretty much that. Actual latitude is 48.4, so an error of 1.4 degrees, which is pretty damn good for that. What that shows is that the Earth rotating imparts a force that we can measure. And anybody can do this experiment. And anybody that does this experiment will find that the amount of drift that they get correlates to their latitude on Earth. Again, showing that the Earth is definitely rotating, because there's no other explanation for why you would get that drift off of the straight line path.
Did the pendulum start from zero, or did it get artificially moved?
I mean, that's irrelevant to it drifting off of the straight line path. That's not the point of the experiment. The point of the experiment is when it is swinging, that will have forces imparted onto it. We don't expect it to start swinging on its own, but when it is swinging, that straight line backwards and forwards path, that changes. And you have to have it moving to be able to measure this. So whether it was an artificial or, start for the swing is irrelevant to what we're saying. The fact is, when it's swinging, that is when we can measure the rotation of the Earth based on the drift of it. So the way that he started it, just in case you didn't see, was like this. He's got a lighter and he's got it, hung up. He just burns the string behind it, and there it goes. Which means it's going on its straight line path, and they can measure the drift of that straight line path, which they do, and they get 7.89 degrees, as predicted, based on the Earth being a globe rotating at 15.04 degrees per hour. Thoughts?
Let's see what the pendulum does from zero.
What do you mean what it does from zero?
Just let a pendulum hang with no swing and see what happens.
It wouldn't do anything as expected. There's no reason why a pendulum would just start swinging on its own, because the pendulum itself is rotating with the Earth. It's all about conservation of momentum. Things just don't start moving on their own when they're already moving within their own reference. What's important is that when it is swinging, right? When it is going backwards and forwards, you can then measure the amount of drift off of the straight line path. That is the measurement. How the pendulum started is completely irrelevant to the discussion.
Well, I'm just saying he had to burn the string, so the string didn't burn all at once. I'm sure it kind of, singed from one side to the other.
Yeah, but the whole thing's still going in a straight line path because it's attached to a pivot point. That's it.
You can see it bouncing when he let go.
Yeah, so and it still just swings backwards and forwards. A pendulum will naturally get even if you kind of wobble it to start with, that it naturally swings backwards and forwards just in a straight line path. And that's what he did is repeatable by anyone, right? And not only is it repeatable, but it's predictable. They can make a prediction of how much drift they should get, and then it matches that prediction, which is what science is all about, right? The only way that you can get this angle to correlate to your latitude on Earth is if the Earth is rotating and there's Coriolis forces being imparted onto that pendulum.
Well, I mean,
measurement of the Earth rotating. Well, it's clearly not stationary.
Where was this location?
Somewhere in Canada, I think, or maybe like North United States. But that's the thing. Anybody can do this. Anybody on the planet, right, can do this experiment themselves. Just need a really tall thing to attach a pivot point to and a pendulum that swings, right? If you did it at the poles, then you would get one full rotation in 24 hours. If you did it at the equator, you wouldn't get any drift because that's where the Coriolis force wouldn't be applied to a straight line path swinging backwards and forwards. So you can make a prediction. If the Earth is rotating, this is what we expect to happen. And then set up the experiment and see if it does happen. And it does. Every Foucault's pendulum in the world is able to give you your latitude on the planet based on its period of rotation and the angle of drift. That's all you need. Which
that to
is
me still
absolute evidence
doesn't,
the Earth is rotating.
That still to me doesn't apply the point because of the crosshatch that it creates. It's still crossing that dot, that center point.
Yeah, that's where that would be directly below the pivot point. That's the entire point of the experiment.
But that has nothing to do with where it's located above on the wire.
Yeah,
so
well,
when you put it on
point,
the wire,
right?
And then that's all stationary, and so it's going to swing from that point.
But it should just swing backwards and forwards, right? It should just swing backwards and forwards. But what you get is a drift. It doesn't stay just backwards and forwards. it drifts in a clockwise direction. That's how they were able to measure the angle of 7.89. Right? Because it didn't stay going in a straight line. There you go, 7.89 degrees. If the Earth was stationary, then you wouldn't get that angle. You wouldn't get that drift in a clockwise direction of the swing of the pendulum. Right? That's the thing. If the Earth is rotating, this is what we expect to happen. This is the prediction of a rotating globe Earth. And there is but there's also no explanation for it on a flat Earth.
But that's treating that center point like it's the center point of the axis of the Earth.
No, it's not. It's just that is the pivot point of the pendulum, that's all. Showing that the Earth is rotating independently to the straight line path of the swing of the pendulum.
So with that same number and that same distance, can you calculate the same speed of either the sun or the Earth spinning?
Well, this method wouldn't be able to calculate the sun, but this method, or any Foucault's pendulum, can calculate the speed of the Earth's rotation around its own axis, which is 15.04 degrees per hour, according to all the experiments that we do.
And that lines up with the speed per hour.
Yes. 15.04 degrees per hour. That's what we expect to happen. And if that is the speed the Earth is rotating, then what we saw in the experiment I just showed you is what we expect to happen. You make a prediction, you test the prediction, see if it happens. That's science. So,
but I'm saying, what is the speed?
The speed
you
of
say
what?
the Earth is rotating at a certain speed, and I'm saying...
Yeah, 15.04 degrees per hour. That's how fast it's rotating.
What is that in kilometers?
You don't spin in kilometers. You rotate in degrees per hour or RPM or radians. If you're talking about the tangential velocity at his particular location, I'd have to find out his exact. I'm not sure of the maths of where he is in particular. I'd have to figure that out. But the entire planet is rotating at 15.04 degrees per hour, or 0.000694 RPM, which at the equator means that the ground has a tangential velocity of about 1,012 miles per hour.
Right, 1,000 miles an hour.
At the equator, yes.
I'm saying, so does that number on the pendulum, that distance,
it matches, yes.
That matches all of that.
Yeah, because you can calculate the degrees per hour and then compare it to the circumference of your latitude, and you could then figure out the tangential velocity, and it would match.
Yeah.
And that's the thing, it matches. We expect this to happen, boom, it happens. And there is no explanation on a flat Earth. That if the Earth is non-rotating, then why do we get a predictable drift from a pendulum? What on a flat Earth could impart those forces?
I mean, I'm willing to take it a different route and say, why wouldn't a from zero pendulum move?
Because of conservation of momentum.
See what I'm saying? If it's on a different point, even though it's not the axis, you're just on the outside you're trying to make your own axis for something that's moving in one direction. So the axis moving in Canada from where we say the North Pole axis is, how is that going to do the same thing?
Because wherever you are on the outside of the globe, you're going to have a different amount of Coriolis applied to you depending on how far away you are from the poles. The most Coriolis in this case would be on the poles, where it'd be 0 applied at the equator. And that's why you can use the drift of it to figure out where you are on the planet, or at least figure out your latitude, and then you can look at the stars and go, okay, well, I must be in this exact location. But there's no explanation for it on the flat Earth, and a pendulum wouldn't just start drifting, just start swinging on its own on a rotating globe, because the pendulum itself is also rotating with the globe. That's conservation of momentum. That's like physics 101.
So basically, it would be moving due to gravity pulling on it.
No, that's kind of what causes the swing. You can actually you could from that, if you knew the weight of that pendulum and the distance that it was swinging, you can actually calculate the gravitational acceleration as well, based on the period of rotation and the amount of distance that it takes to swing. You could calculate the gravitational acceleration. You could derive that from the same experiment. And then you would get about 9.8 meters per second squared. But what's keeping the pendulum moving is irrelevant to the actual experiment. What the experiment is about is when the pendulum is moving, does it keep swinging backwards and forwards in a perfect line, or does that line drift? And it drifts, as expected. Therefore, the Earth must be a rotating globe.
I would say that, you're still dealing with an artificial movement. Somebody else started it.
Yeah, that's irrelevant to the experiment.
Why isn't it being still and watching it move or not move a better experiment for something that's spinning?
Because you wouldn't expect it to start moving on its own. I just went over that. Conservation of momentum says that anything that's just sitting there, so say this is the pendulum on the rotating Earth, it's rotating with the Earth. So there's no reason for it to just start moving on its own. But once you start that movement, right, then that backwards and forwards movement you can use as a measurement. But it has to be moving in the first place for Coriolis forces to be imparted on it. So whether it's natural or artificial means to start the movement is irrelevant to the measurement that you can obtain.
What direction did they drop it from? I mean, let's include
again, that's irrelevant. It doesn't matter. It doesn't matter if you dropped it from east to west, from north to south. It doesn't matter. Where you are on the Earth, you will still get the same amount of drift. It doesn't matter which direction you started it from, because the Coriolis force is applied the same whichever direction you're going.
So is that the only experiment that they did that with? Did they take it somewhere else?
There's the same experiments all around the world.
With that technology that he had?
That's not technology, that's just a pendulum. And that's the thing, anybody can set up and do this experiment, and it's been done multiple times all around the world. Every pendulum in the world, you can calculate your latitude from.
I think it still is in the artificial movement.
That's irrelevant. That's completely irrelevant to the measurement.
If it was really spinning, it would have an effect on it without.
It does have an effect on it. It's the drift off of the straight line path. But there's nothing about a pendulum on a rotating globe that says it should start swinging on its own. We see what we expect to see, right? You're making up something that you expect to see, which isn't true, right? That's called a straw man argument. What we expect to see, we do see.
I'm looking at everything. How he burned it, it wasn't clipped, or it wasn't
burning it is generally the easiest way to avoid other things getting involved.
I don't know. It's a moot point as far as
it's not really a moot point. It's a measurement of the rotation of the Earth.
What I'm trying to include and show is unnecessary. It's all right. Go ahead.
So, but anyway, that's just one of the measurements of the rotation of the Earth. I showed you another one earlier with Bob and his fiber optic gyroscope. There's many, many, many more. If you go to mctoon.net/spin, there's a whole list of measurements of the rotation of the Earth using free-hanging disks that are spinning, using superfluid phase coherence, using many light-based methods, different mechanical gyroscopes, and they all show the same thing, that the Earth is rotating. Every time you try to measure the rotation of the Earth, you measure the rotation of the Earth. There isn't, and this is very important, there's not one single measurement ever of the Earth being stationary. Okay? So, basically, there's no explanation for that on a flat Earth. Only on a globe Earth. So what's your thoughts?
Most of that is still, to me, is artificial.
I mean, again, that's irrelevant. The drift isn't artificial. That's what you've got in every pendulum in the world ever. You'll get that drift.
Started from zero. If it doesn't do anything,
what do you mean?
Zero,
start it from zero. What do you mean? What do you mean? Start it from zero.
Just let it sit. Don't touch it. Don't let it.
But you wouldn't expect it to swing. That's not an expectation of a rotating globe for the pendulum to start swinging on its own. That is not what should happen because of conservation of momentum, a very basic fundamental physics thing. You know, the conservation of momentum says that there's no reason the pendulum would start moving on its own from zero. You need to get the pendulum moving. But once it's moving, you can then measure the forces imparted on that freely moving pendulum. That's the important part. It doesn't matter that it doesn't start moving on its own. It's completely irrelevant to the experiment and the measurement. How the pendulum started is irrelevant. But again, it matches all the other measurements as well. That's the thing. It matches all the measurements that we tried to do.
So do you feel there's a vibration that the Earth has as a sphere?
Do I feel there's a vibration the Earth has as a sphere? What do you mean?
Like a frequency. Do you believe that the Earth has a frequency?
Every atom in the universe has a vibrational frequency.
Okay, and Earth as a whole, do you think it has its own frequency?
When all the atoms on Earth will have the same vibrational frequency.
And so do you think that has waves?
Do I think the frequency has waves?
Do you feel like those affect anything artificial?
No. There's no reason why the vibrational frequency of quarks and gluons should have an effect on the physical properties of the universe in any meaningful way. It's just a natural thing that you can measure, and every subatomic particle in the universe has the same vibrational frequency. It's just a natural property. But that's not something that would affect anything in day-to-day life.
Why wouldn't that be in effect?
Because it's just natural movement of you know. I mean, dude, you'd have to break down. It goes a lot further than just atoms and frequencies. It goes down to the energies imparted by, you know, strings and virtual particles and quantum foam. It's not something that is relevant to what we're talking about.
Sure it is.
In what way?
Because you're using a pendulum and it's on the Earth. And if the Earth, whatever they have the structure for that pendulum is attached to the Earth. And if the Earth has a frequency, why wouldn't that vibration affect the structure?
The structure has the same. Okay, so the structure has the same vibrational frequency as Earth. Every particle in the universe has the same vibrational frequency, and it's not really like a physical thing. It's more just movement of energy within a subatomic reference frame.
But it's still movement.
One second.
So why?
Just give me one second. I have to respond to a dumbass in the chat, Gary Webenenga. A pendulum proves nothing. It can't start on its own and keep going on its own. Shouldn't conservation of momentum keep it going after you start it? No, that's not what conservation of momentum is. You have an inertia that will, go away over time because, the pendulum has to be going through the atmosphere, which is friction. Conservation of momentum does not in any way say that it should keep going. Gary Webenenga, you don't know what conservation of momentum is. I understand why you're too scared to debate me. Sorry, Ben, I do apologize. There's a dumbass in the chat.
No, you're all right.
So anyway, yeah, there's no reason why a pendulum should start moving on its own, and the natural vibrational frequencies of the universe have no effect on experiments in this way. Because it's all the same. So basically the fact that all the measurements match up, be it from a gyroscope, be it from a pendulum, be it from superfluid phase coherence, it all shows the same, that the Earth is rotating. So we have to conclude that the Earth is rotating.
I don't know.
I'd advise you look into it and maybe learn the maths and the physics behind it. That would be very helpful to you.
All of those are personal and experimental apparatuses. So they're in different locations and all of that. So
and they all show the same thing.
The same amount of momentum. You're still dealing with artificial movement. Somebody moved it, or a machine moved it. You put it in motion.
You keep coming back to that, but again, that's irrelevant. It's not the is it moving or not that's important. It's when it is moving, can you measure a drift? Yes or no? That's what's important. The fact that the pendulum didn't start on its own, which again is not what we expect to happen, is not what the experiment and the measurement is about. It's about what happens when it is moving, which shows that the Earth is rotating. It's as simple as that. Would you like to see a picture from space taken in the last 10 minutes?
I just, I do a bunch of different stuff, but we know the hooks, screw hooks. And what is the apparatus that this is swinging from?
It's just a pivot point.
Yeah, but what kind of pivot point is it? Is it a ball bearing pivot?
I'm not sure. I imagine that they
took.
I mean,
is it a ball bearing pivot?
I imagine they took every care to make sure that it was a minimal friction. But again, the type of pivot is actually irrelevant.
Well, we're just wondering because.
So anyway, I want you to look at the screen now.
In the fisheye hook.
So this is a picture that was taken in the last 10 minutes. What do you think?
It just looks like that's what they zoomed in on to take a picture of.
Yeah, that's taken from a camera on a satellite called Himawari 8. Takes a picture every 10 minutes. Beautiful, isn't it?
It's cool. Still got graphics.
Well, yeah, they overlay the countries to make it easier to see. You can turn that off.
Oh, it's okay.
So, yeah, the picture from space, that's always good. Have you got any pictures of the flat Earth from space?
Yeah, they take pictures all the time.
Oh, really? I've never seen a picture of the flat Earth. Oh, wait. Someone's just sent me a picture of the flat Earth. Oh, where's that gone? Oh, well, apparently here's a picture of the flat Earth taken from space.
Yeah, I don't believe that.
That's the Great Atuin. So, I think that we've kind of gone for everything, right? I showed you that crepuscular rays are pretty much only possible from parallel source, and the fact that we have ones coming from underground. Water being level is an effect of gravity, and level means the curvature of the Earth. You can't zoom boats back in once they've gone beyond the horizon. There is no ice wall because of the biannual yacht race of 14,000 to 16,000 nautical miles. And then I showed you measurements of the rotation of the Earth. Let me just show you quickly one little measurement of the curve of the Earth.
If you're seeing through this hole, through the next hole, and seeing the light at the backboard, or at 17 feet off the water, the Earth is flat. If he's holding it up at 23 feet high and we're seeing the light, well, that's because the Earth's curved. So I should only be able to see it when it's at 17 feet. Okay, go ahead and drive down there, Enrique. You're going to hold the light there. Enrique, how high is your light?
17 feet.
I mean, it's as, we don't see you, Enrique. Lift up your light way above your head.
Everyone ready?
Interesting.
Interesting.
Interesting there.
Yeah, so there is another famous flat earther, Jism, demonstrating the Earth's got a curve and finding it very interesting.
What was the distance they were apart?
I'm not sure of the exact distance. It's covered more in the Netflix documentary that's from. But basically what they did was they set up two boards that were relatively close to each other, and they had holes in those boards, right? And then they drove a distance away, and they had a camera looking through one hole and then looking through the next hole, right? And that meant that if, from back here, the Earth was flat, they would only have to hold the camera up this high. But if the Earth was curved and they've gone down, they would have to hold the camera up a bit higher for it to be seen through those holes. And what they found was that they had to lift the camera way up high for it to be seen through those holes in the boards, which wasn't what they expected to happen. They expected to just be able to see it because they think the Earth is flat, but their results were the opposite of what they expected.
So, but the distance apart was the same sea level, or did somebody have to adjust due to the road going down?
Both of the holes were
up?
exactly the same distance above sea level. Yeah, and they actually did it along the coast as well, so to make it like extra fair and extra, along the sea. But if you want to see more measurements of the curve of the Earth, go to mctoon.net/r, where he has a whole list of measurements of the curvature of the Earth and actually calculate the radius. So that's probably a good time for us to start shutting down, because we've been going for nearly 2 hours now.
Yeah, most all of that is experimental stuff that's artificial. That's not something that we go out and observe. A pendulum, I mean, it's still artificially started.
Yeah,
so
that's irrelevant,
it's not something that's naturally occurring. That's not a naturally occurring thing in nature. A pendulum does not naturally occur.
Everything's in nature. We're part of nature, therefore everything we do is part of nature.
Of course, but where is a pendulum in nature?
I just showed you a pendulum in nature. You don't have to have it swinging in the jungle all on its own for it to be in nature. In science, when we're talking about the natural world, we mean anything not supernatural. So anything natural in science literally means everything that is physical. Me, you, equipment we use, machinery, atoms, air, everything. That's natural. In science, unnatural is like supernatural, ghosts, God, things that you can't test, things you can't experience, right? So that means that the experiments that I showed you, they were all in nature, according to science.
Sure, but nothing that we really discussed was natural.
Well, it's all natural. Like I said, anything we do is natural.
Most of it is experiments from somebody else or other people. When we go outside, the sun doesn't have to be way away. It doesn't have to be 93 million miles away.
I mean, it
It
is
can
though.
be
It's been
smaller
measured.
and local.
They do radar bounces off the sun, and there's like a 16-minute round trip for the light to come back, showing that because we know the speed of light is 180,000 miles per second, a 16-minute ping off of the sun means the sun has to be about 93 million miles away. Again, it's a measurement that you can't really, argue with. And when in nature, naturally, when we go outside and we see the sun, we don't ever observe the sun to change in angular size. So, right, what I'm going to do, I'm going to ask you to give your final thoughts. All right, I'll give you 2 minutes to just, any thoughts about anything we've said today, anything that you said, and then we'll start closing out the show. So over to you, 2 minutes for your final thoughts.
No, a lot of the points, well, a lot of that is mathematical. A lot of that was in realms that I never dive into as far as that. So it kind of left me a little, I guess, hush mouth. What I see is natural observances, and what the perception of that is. The sun doesn't look like it's that far due to certain conditions in the sky. Vanishing points and all of that makes sense. There's different things that people discuss, different talking points about Antarctica and all of that. The solstices and the lunar eclipses, all of that stuff I've seen explanations for in the flat earth model. I'm a little extreme in mine. I think that it's a whole plane, and they can't go out. It's probably just cold until you get to a next region where I think is what we call our planets are just other sun and moons in a different region on a flat plane.
Interesting.
So my thoughts and stuff, a lot of times I'm discussing them on Facebook and whatnot, where I can kind of research at the same time and or have memes ready and stuff like that I've collected over the years. But like I said, most of what I did was just self-research. I've looked at all of the stuff that you've seen or that you've shown me. I've seen stuff on that. I've seen more examples of what we call the ship going over the curve. Like I said, this was years ago, so everything that we've discussed today is some talking points that I haven't normally seen and haven't applied myself to. So, it may seem like, hey, flat earthers got their butt kicked.
Well, anything you got questions on, I'm happy to send you more info on this stuff.
It's not even about convincing anybody or nothing like that. It's just go out and observe for yourself,
Okay. I do appreciate you taking the time, Ben, and I also do appreciate the fact that you've been polite and patient with me. Not a slight on you, but generally flat earthers are assholes, right? And that's just a fact. I've got one at the moment threatening to kill me. I've got one wanting to fight me. I've got one trying to expose me for being a fake military veteran. Flat earthers in general are horrible people, homophobic, transphobic, racist. But you have been a delight to talk to, Ben, and I sincerely appreciate you having a civilized discussion with me. Thank you very much.
Oh, you're welcome. Yeah, I find no reason to, get all crazy and irate about it. I've seen it. I've been called all kind of names, stuff like that. It's kind of funny, but it's just like, man, let's just discuss it,
I mean, I'd definitely like to have another discussion with you as well. Maybe go over some more of the points that you've got, and maybe if you can have a look a bit more into the stuff that I've shown, we can have a bit more of a deeper conversation on it. But I do want to thank you for taking the time and coming to speak to me today, Ben.
Anytime, anytime. Yeah, I'd love to. Like I said before, I just needed to brush up and get some of my talking points down. I'll definitely be ready next time.
Cool.
We can talk in between. So,
Well,
cool
stay in
beans.
touch, and I've got a couple of people that might like to have a conversation with you as well.
All right, cool.
All right, Ben. Well, you take it easy, and I will speak to you soon. Thank you for joining.
All right now.
Wow, that was a non-dumpster fire, guys, which I thoroughly enjoyed. Uh, actually, it's nice to be able to, when someone asks you a question, right, and you actually get the chance to answer that question. It's quite nice when talking to Flat Earth, because normally what happens is you ask the Flat Earther asks you a question, and then they shout at you whilst you're trying to answer the question, like you saw yesterday with the Flat Earth gangster that I debated. Talking to this guy, a lot of personal incredulity, a lot of straw man of the globe, obviously a lack of knowledge in general about physics, but that is somebody that I think is more likely to come back to the globe, because he was willing to listen to me. Yeah, there was a lot of, but this doesn't happen because this and straw man and stuff, but maybe give the guy a bit more knowledge of physics, a bit more information, maybe a chat of MC Toon, maybe a chat of an ex-Flat Earther, and that seems like somebody that we could, help and have nice chats with. So I do appreciate it when they're not complete and utter fucking assholes. So I think that may have been the first time I've sworn today. Wow. So tomorrow, there's another debate with, if you go into the community post I put up yesterday about Jake and look at the pinned comment, there's a guy called Scott Caldera and his cousin Aaron Caldera, both fucking crazy, and I'm going to be debating one of them tomorrow. I think it's Aaron. And he wants to talk about the Diomede Islands in Yesterday Island and Tomorrow Island, because he thinks that the sun is 6 hours behind in one, but he doesn't understand time zones, and in fact it's actually like 21 hours because one's in the day ahead. So I've got that. Sunday be a new episode of Flerfs Idiots. Editing is in process. That's being done. And then Monday, hopefully I'm trying to get Rachy back on for round 2, which will be moderated by Seek Truth, Speak Truth if he's still available. But tonight we're going to read the super chats. Once again, the support you guys give me is insane. It blows my mind every time. I can't believe that you guys are so generous during my streams. If you're not able to support me financially, the best way to help the channel is to share what I do on social media, Facebook and Twitter especially. But let's read the super chats for today. Baron Von G for $4.99. I just have to say, this very into the debate, this man has brought a pen and paper as evidence in 2021. Hey, it's more than most Flat Earthers bring. Baron Von G $1.99, he's gonna doodle. He did a bit, didn't he? Zachary Tansey for $2 rather. Why have people forgotten Amelia Earhart? Yeah, you're absolutely right. Throw the Dwarf for the House of Trog, $5 Australian. Question for the Flat Earther, with the temperature of the sun being what it is, why are we not dead when it's so close? Kind of goes on for my question, why does it not get hotter when you go up a mountain? Eddie Reese has been a member for 3 months. Remember, all members get 1 free super chat a month. This is his. He says, don't disrobe for Jake, disrobe for yourself. If you notice, there is a poll up there, guys. The poll is, should I take off my clothes for Jake the Asshole? Because Jake sent me an email, as I explained in my community post, saying he's going to challenge me to take off my top for some reason. He wants to get in a cage and fight me, and he wants me to take off my top. He's got a crush on me, doesn't he? So if the vote gets enough for yes, at the moment it's 46 for yes and 54 for no. If you get to more than 50% in yes before I finish reading the super chats, then I will disrobe for Jake. Because why not? MEB, $5, 1 tablespoon of solar material, 90 miles above Earth, would incinerate all of life on Earth instantly. So why is the upper atmosphere so cold? My question exactly. Baron Von G, $4.99. No way he's actually doodling. Bless his heart. Yes, he is. Rachel Daniel says, not for Jake. No, I'll tell you what, I'll disrobe for you guys. Or you could just go to my OnlyFans. Mr. Unite for the Children for $5 says, given a triangle sides 1 and 1 and 1, how many licks does it take to get to the center of a Tootsie Pop? That's a question that can never be answered, I'm afraid. Norman Dixon for $5 says, Ben Ed Cole. Cool name, by the way. What causes whiter guys in Yellow Park if water always seeks its level? Pressure. Steve6464 for $5 says, Benjamin, could level in sea level mean the same as height, stage, or point? So instead of sea level flat, might it mean sea height? Yeah, they don't get that words can have multiple meanings. JRock69 for $6.99 Canadian says, I zoomed in on my crack and balls. It still never goes from an innie to an outie. What the heck? Flat Earth ruined my love life. What? Norman Dixon, $5. If the ship is the vanishing point, it would have vanished in totality. It's in the name. Yeah, I tried to drill that in. Then we got Retro Staffer with a keep it up €5 emoji. Thank you very much. Technomancer Magus for $10 says, fight the tight shirt by taking it off. That said, is there a way to get the opening song that plays during your 5, 4, 3, 2, 1 countdown? The da-da-da-da-da-da-da-da-da-da. I'm pretty sure that particular bit, the 5, 4, 3, 2, 1, I got off of Intro Champs. And I think that music came with it, maybe? I'm not sure. Lord Luminous Pooh for $2 says, Ghostbusters was great. Busting makes me feel good. Existential Nihilism says for $4.99, please ask Mr. Flerfs to draw a map to lead us to his lost brain. The right hand side of the stream is an entertainment black hole. Zachary Burns for $6.66, Hail Sagan, slow down, you're about to make his head explode. Information is kryptonite to Flerfs. Existential Nihilist $4.99, poor Flerf, look at him, drooling on himself, farting in the bathtub and trying to bite the bubbles on the... Not an image I wanted, thank you. Alison, $2, insert usual question, stay hydrated, peace out. No one's ever going to answer your question. Well, no flat earther is ever going to answer your question because it ruins them. Alison's question is, why is all navigation based on the globe? Answer is, because it's a fucking globe. Eddie Reese for $2 says, did he just say natural observature? I missed that, did he? Fuck's sake. The Sun Express, $5, there are going to be generations of us with chronic forehead concussions if this Flerf nonsense carries on like this. I really should start giving facepalm warnings at the beginning of my streams, you're right. And then Siggy Sigwald for 500 ARS. Thanks for your sacrifice. I reckon debating Flerfs must kill you inside a bit. I'm not sure what ARS is, let me check. It's Argentino pesos. Thank you very much for that, I do appreciate that. But that's going to be it for tonight, guys. Tomorrow, a new debate. And I'm pretty sure tomorrow is going to be a fucking dumpster fire scene from space. And a new episode of Flerfs Idiots on Sunday, which is my video response to Jake. Flat Earther wants to fight me. But that's been it for tonight. I do appreciate your constant support and you being in the chat. There was 620 here. I think it peaked at one point, which is incredible. But for now, guys, remember, stupidity is not a right. Fight the flat earth. Fight the flat. 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 Didn't get there with the poll, guys. I might still take off my clothes. I mean, why not, eh? Zachary Tansy, $5. Jake plus Cage minus shirt equals nobody wants to see him, let alone hear him.